Thank you. Hello everyone. Again, first of all, we would like to say that being in Kosovo, for B-sides as a Turkish people, means a lot for us because we know our connections. We will start with a quick introduction with Fatih. Oh, it's not working.
Oh my God.
So, it's Aytek again. Currently, I'm working as a blue team engineer at Picus Security. Before that, I was working as a part-time. I'm kind of fresh graduated last summer. Before also, I was working part-time, as I said, and then I converted to full-time after graduation. Before Picus Security, I was creating detection contents to SOC Prime as a freelancer. And some of my main areas are security research and development, threat exposure management, endpoint security, threat research, and threat intelligence also. One of the fields that I improved a bit more than the others is detection engineering. You can see more than 200 detection rules on SOC Prime platform. And I have some badges from SOC Prime also. One is all-time top detection content authors by customer choice. And the others is privilege escalation detection master. And the last one is Ankara professional. And beside of my security career, I was a professional goalkeeper, as you see. I play 10 years, it doesn't have to be cybersecurity to talk. You can come and find me after the presentation to talk about Vedat Muric, or I don't know, whatever you want. Thank you. That was about myself. Fatih will continue.
Hi everyone, this is Fatih. I've been working in the cybersecurity for over 7 years. Currently I'm working as senior blue team engineer at Picus Security. I worked on various digital forensics, incident response, and threat research teams throughout my career. I focused mostly on endpoint security and developing security tools. Also, I am interested in vulnerability research. I've also participated in a cybersecurity organization as a speaker and trainer. You can reach details from my blog. Thank you.
So, what you're gonna hear from us today, we will start with question why we created this tool, and then we are gonna try to explain concept and architecture. We will give some use case example. We are gonna see Perceptor's outputs. We are gonna explain some challenges that we faced through during the development phase, some impact and benefits, some exciting future works, and then we are gonna come to conclusion, and then after we are gonna take your questions. So why we created this tool? First, especially when I was creating detection contents to SOC Prime, I had to read 10, 15 threat reports each day, and there were no automated pipeline to extract all the patterns, all the behaviors, and then maybe if I can create contents or not, but with Perceptor, we are gonna try to solve it. And also, one of the main point of Perceptor is taking time from the back of the analyst, and each day during this year, 2025, every day we are seeing new APT groups, we are facing new vulnerabilities, bypassing techniques, threat intelligence can keep up with the all-growing volume of threat intel, and if there is not automation tool for this process, security teams can be overwhelmed. So Fatih will explain some key capabilities.
Yeah, so what's Perceptor, what we developed? With Perceptor, we can analyze threat reports quickly with AI, and we can use effectively in detection engineering operations. Actually, we designed an AI-powered approach. This is the backend, and everything is connected with this. We analyzing any threat reports with AI-powered approach, such as APT campaigns, malware write-ups, CV disclosures, emerging threats, and etc. With this, we obtain a contextual threat intelligence data, such as threat summarization, IoCs, TTPs, and execution chains. And using this contextual data, we are automating the detection content creation process. We are generating Sigma and YARA rules, also their SIEM queries. And finally, we are finding the global Sigma rules matched in the wild. Workflow. Let's take a look at the workflow steps. We have 7. I take we have 7 main steps. Perceptor first takes the URL input of the threat report. It passes the content. If there are images, it analyzes these images using OCR, optical character recognition. and it normalizes the entire report. Next, extracts all IoCs, TTPs mentioned in the report, and then learns all the attack details and summarize it. It identifies the target sectors relevant to the attack and determines CV relationships. Also, it correlates the threat actor or malware families related to attack. After the report is analyzed, the detection content creation process begins with YARA rule generation. The YARA rule is automatically developed using indicators with our algorithm. Likewise, the Sigma rule is automatically developed using IOC TTP mapping. The final rules is ready for use after going through an AI-powered optimization. The created Sigma rules are then converted into Splunk and QRadar queries, providing ready-to-use detection queries for SIEM systems. Finally, we don't only rely on the contextual data in the report, but also use this data to search for detection content matches globally. Thus, contextual data is also associated with global detection content.
Thank you. So I will try to explain our modular structure, like which module that we developed for some functions. First, we have module for IOC TTP, like basically all the pattern extraction. Like you can understand from the name, we are trying to extract all the patterns, like not just IOCs or TTPs, like with the chains, like suspicious parents and the child processes. And then we are trying to analyze them to maps them to MITRE attack, like MITRE IDs. And then we are identifying malware behaviors, all the chains and execution techniques. Which technology we used? We used human message and runnable sequence functions from LangChain, and also requests for behavior extraction. Beautiful SOAP and regex for web scraping and parsing. And for AI-assisted threat analysis, we use LangChain and GPT APIs. So our second module is for image processing. This is for extract hidden the all indicators from images and screenshots, because it can be too important that, like, even if you are reading the report, you can see that all the chains, all the patterns can explain in the image. So that was crucial to like process all the images. And we are using OCR to extract all obfuscated and embedded informations. We are capturing JavaScript generated content and dynamic image from the URL, like which includes threat report. We have also conversion of every type of image, like CFG, PNG, and JPEG. And first, we have like technologies PyTesseract and Pylo for OCR, and we are using Selenium and Chrome driver for web-based screenshot capture. The other model is for threat analysis. It's basically summarized threat reports to extract CV details if it includes in the reports, targeted sectors and attack chains. And then it identifies all industries, like which targeted, and all campaign detail with threat actor groups names. We are using LangChain and OpenAI technologies for AI-powered analysis. We are using prompt template and runnable sequence function from LangChain also for prompt engineering and summarization. When we will come to POC results, I will explain these ones with more detail. And of course, for structured data processing, we have JSON format. The other module is for detection content generation. It basically generates Sigma and YARA rules dynamically based on like all patterns from the threat report, and then using AI to refine rules for accuracy. We have PySigma, LangChain, and GPT API for Sigma rule generation. And for rule optimization, we are using LangChain and OpenAI also. And for the format of ruling, we are using YAML format. And for YARA rule generation, we created our algorithm. Also, I will explain our algorithm when we will come to our POC results. And for user interface interaction, for now, Perceptor is based on command, like terminal based, like Fatih was too obsessed to take to stream in it or like some kind of web UI. But I was also obsessed with stick in terminal because we hadn't that much time. So as I said, it's based on terminal for now. It displays real-time analysis results on like CLI-based UI. We are using rich library to format output for readability. We are using rich library for format output. That is important because we are going to see a lots of information of the execution of our tool. Like we are going to see all summarization, CVE details, detection contents. So it was also important to show these results with structured format. So, and the other technologies we are using for user interaction and login, we are using SYS and CSV technologies. And our last module is for global Sigma match. We are parsing of thousands of Sigma rules in like 20 seconds. We are focusing on the selection block on Sigma rules. We are parsing it, and then we are taking like keywords, and then we are making token of them, and then we are trying to find these tokens in our IOC tables. We are focusing on the, like as I said, the selection block, and then we are using regex tokenization with dynamic stop word filtering. So what is it about? Like stop word filtering, you can add stop words to reduce false positive. Like, cause you can see that some of Sigma rules includes like Windows or Microsoft indicators. So if you want to reduce them, if you want to reduce false positive, you can add stop word like with configuration file. And then we are giving match ratio competition between report tokens and Sigma detection content. I will explain with more detail when we will see POC results. We use C-safe loader for performance. We use concurrent features for parallel processing, and of course regex for tokenization. So I will try to explain two technology that is too important. Like we can say these two technologies like core concept of Perceptor. But before that, I'm thirsty. I will drink my water. Okay, so LangChain. So it's basically an open source framework designed to streamline the old like development applications powered by LLMs. Instead of limiting LLMs for isolated prompt response patterns, LangChain enables the creation of multi-step, data-aware, and agent-based applications. And with LLM feature, it powers natural language tasks using OpenAI and Hugging Face. Hugging Face, I wanted to streamline here because if you are interested in AI, you can follow every updates on Hugging Face. If you didn't check yet, you can definitely check it. And with memory feature, we can enable dynamic and stateful interaction. And with prompt engineering feature, we were able to create tailored prompts for optimized outputs. And with agent executor, which we didn't use in Perceptor, you can execute tasks dynamically using external tools. So with that all features, what can be done, you know? At the final chain, you can create like question answering over documentations. And also you can create summarization, which we did in Perceptor, to create summarization of threat reports. You can create chatbots, you can query tabular data, you can interact with APIs, which also we did in Perceptor. You can think like the LangChain is a bridge between user and GPT. With LangChain, your inputs getting like more informational and more understandable. So you can interact with APIs, and after like most of UI, you can create some functions for code understanding. So which features we used in Perceptor with LangChain? LangChain's prompt engineering features give us the opportunity to construct structured prompts to extract all the patterns and create detection rules. And with memory management feature, we are using entity memory to track previously processed threat intelligence data, ensuring context continuity. You can think that like you are working on the same tab in ChatGPT on the API level. With LangChain, it's possible to use API with that memory management feature. And the other feature that we use in Perceptor is chaining functionalities. We were able to connect AI components like GPT for like seamless automation. And the last feature that we use is for enhanced automation. It can streamline all process, like all threat intelligence process, for reduce manual effort and improve accuracy. So what is AI approach? How we are using AI in this project? Like in this diagram, we try to illustrate the AI-driven structure behind our automation pipeline. On the left, we see the user interacting with LangChain-based interface, which coordinates the core components, the LLM, memory, prompt, and agent. The green blocks indicate the elements we actually utilize. For all three core functions of the system, we rely on the OpenAI O1 model, like which consistently provided the most optimal and balanced result in our evaluations. Like although models like GPT-3 or GPT-4 Turbo are available, we found that O1 outperforms like them in detection quality and response clarity also. However, like using O1 at the API level requires a certain credit threshold. Like even if you have enough credit, you have to spend some money to use O1 on API level. It's not a good thing, but it is what it is. Like on the reasoning effort side, two of our three functions operate under high settings, while the third runs at medium. We initially avoided using high for all because it increased response time significantly. Like if you are gonna put high for all of your functions that you are gonna use to interact with GPT, it's like the time gonna be like 30 seconds, 40 seconds more. And in the end, for each proceed URL, we make 3 calls to the O1 model, 2 with high reasoning effort, and 1 with medium, which results in average cost like $1.50 per analysis. So you can think that like if you want to decrease or increase the cost, you can consider that for using other models. Like it doesn't have to be GPT also, but LangChain integrates with GPT. That's why we use GPT. And for reasoning effort, you can choose low or medium to change the cost. So other technology is Selenium. Maybe most of you know, maybe not. It's also open source framework that like automates web browser interactions. Commonly you can use for testing, web scraping, and dynamic data extraction from web applications. Which features we used in Perceptor, like which Selenium features we used. First, we have dynamic content handling. We were able to interact with JavaScript rendered content, making it useful for extracting data from like all modern web pages. And with web element interaction, we were also able to simulate human-like interactions, such as like clicking button, like filling forms, navigating pages, and handling pop-ups. Like you can do like lots of stuff with Selenium. And with headless execution, you can like run without opening a browser window. We use also Chrome driver with Selenium. That's how we are taking screenshots of images. And you can also make it efficient for large-scale automated tasks with this feature. And the other feature we are using it for image processing support. We can capture screenshot of web elements for OCR analysis, enabling the detection of threats in image. That was too important. Why? Because first, we were trying to create functions for all image types. Like we were trying to convert PNG to text, CFG to text, and also like GPX. And then we saw that even if we are gonna create like 10 functions for all image types, we can see the new one on the new threat report. That's why we decided to use Selenium for take a screenshot of the image and then convert it to text and send to OCR. So what are the possible use cases with our project? You can basically turn raw threat intelligence into actionable detection in minutes. Like with Perceptor, you can automate the process of summarizing report, extracting all behaviors, and generating detection content, eliminating hours of manual work for detection engineers, which is crucial, as I mentioned before. And you can enhance detection quality using AI-generated insights. Security teams can reduce alert fatigue by refining existing rules and mapping accurate MITRE techniques and minimizing false positive through GPT optimization. And you can also correlate indicators and behaviors across multiple threat actors. Like you can automatically identify patterns across reports, find recurring malware families, link IoCs to known campaigns, and highlight shared TTPs to strengthen threat landscape understanding. The last thing you can do, you can check if your local detection is already globally known. Like you can map analyzed threats to community Sigma rules like Sigma HQ, allowing analysts to detect overlaps and accurate response based on global intelligence and shared detections. So, after all the like workflows, modular structures, some use cases, now we will check the POC results. We choose a report from ESET, which includes Operation Fish Medley. You can scan the QR code to check what is it inside. By the way, Fatih created the QR code, so if something's gonna happen, find the guy, not me. So, the user basically just need to give the URL to our tool, and that's all user has to do. And then we are starting to process all the images, and the end of the lines, we are seeing threat report summary being generated. And after that, we are gonna see threat summarization. What it includes, we are seeing the threat actors group names, we are seeing some targeted like sectors and targeted regions, and after that, we are seeing severity level for the report. And then we are seeing some key TTPs and some recommend mitigations. Like these mitigations can be too generic, but still it can give like analyst to something. And here you are seeing the reference like where Perceptor took all the information from the report. And then we are starting to see our JSON data, which is crucial. I will explain when we will come through the creating detection contents. We are starting with Sigma rule title, description, confidence level, and some notes. And then we are continuing with some IoCs, which are categorized, some IPs, domains, URLs, email address, which we couldn't find on the report, file hashes, and file names. Also, you can see the references of these indicators. And we are continuing with registry keys, process names, and malicious comments. I want to mention one thing, especially after Daniel's presentation. You can ask that why we didn't use regex for all this extraction. Like, because there are lots of tools for IOC extraction and TTP extraction. But what we are doing with LangChain is taking the whole package of the malicious comments. Like, you can see that we are seeing some DLL sideloading behavior with run DLL, and then we are seeing some minidam comments like with the TMP file, and then we are seeing the registry activity. If we would use regex, like there will be no way. Maybe in the before I show you that IPs, domains, URLs, maybe we were be able to take these patterns, but for like malicious comments, it was like for now, it seems like impossible, but after Daniel's presentation, we might check it. Thank you again, by the way. So, after that, we are gonna see some MITRE mapping. In this part, the cool thing is, we are seeing the descriptions. In description, we are not explaining the MITRE technique. We are explaining why we mapped this technique. So, for example, we can check for process discovery. We saw that the threat actor executed task list command to discover process. Even if this is false positive for you, you have the opportunity to eliminate fastly. And after that, we are seeing threat actors and tool and malware names. And in the middle, there is a reference. And after all the information and summarization, now we are seeing the detection contents. First, we are seeing the YARA rules. Now I will explain our algorithm. When we were extracting all IOCs, we didn't just extract them, we tried to categorize them. And after the categorization, we created a little algorithm. For example, for IPC, use ASCII full word on strings. For domains, use no case for strings. It's really basic and generic, but still it can give something to analyst. And the other YARA rule we are seeing for file hashes, file names, registry keys, and some processes like malicious comments, etc. And after all that, we are starting to see our Sigma rules, which is backed with PySigma. We had some problems for applying PySigma on our tools. First one was you can create Sigma rule with multiple selection with PySigma. And with Perceptor output, we were be able to create Sigma rule only with command line pattern. That's why we decided to use LangChain technology to create another detection contents. When we began this process to use LangChain for creation of detection rules, we think that it's not going to be stable and it can be changed a lot because it's AI output. But what we are going to see is going to be like better results for PySigma for sure. After the PySigma-based Sigma rules, we are asking GPT to refine these detection rules. So we saw that it created Sigma rules, like 5 different Sigma rules. And when we asked the GPT, it created one rule with 5 selection. And after refining the Sigma rules, we are asking for a Splunk query and QRadar query. And after that, what we are seeing now, outputs from LangChain, not PySigma backed Sigma rules. So what we are seeing on the selection part, it's one of the most important part of Sigma rules. It's clear Sigma rule with ends with and contains fields. There are no trash wildcards, there are no trash paths. Like as a detection engineer, I can say this is like ready to use rule. Of course, it can be generic for your system, or maybe you have already, but still it's clean and the syntax is better than the PySigma backed. Other rule we are seeing from the LangChain also is registry activity. It saw on the reference for registry heaps with that patterns, and it created registry rule like the other, no wildcards, no paths, only pure detection block. Another rule we are seeing for create file event type, it understands that this file contains custom password filter, so it decided to create a rule for detect this file. So what we are seeing here is so cool for us because it saw that there are too many DLL files which sideloaded by the threat actors. It literally created a regex for detect all the DLLs at the same time. So other selection, we are seeing some original file names which also include in threat reports as a suspicious or like directly malicious. And the other rule we are seeing is with multiple selections. First selection, we are seeing some PS execution. On second, we are seeing some suspicious VMI usage. On the third, we are seeing Q user comment. And the last, with registry activity. So, after creating all the detection contents, we have possible global Sigma matches. So, what we did here is when we parse the selection block on the Sigma HQ repos, we are trying to find them in our IoC table. If we are going to find them and it's more than one keyword, you are going to see as a matched. So where is match ratio is coming from? So it's basically if you checked Sigma HQ repo before, you can see that there are Sigma rules with 20 indicators, with 50 lines. Of course we love Florian, but some rules can be trash. So that's why if the rule contains less than 5, 10 IOC, it's more important for us. Ratio gonna be high if rule is more low and more optimal way. And here on the Sigma rule title, you can click and you can go directly to GitHub page to deploy to your CM or EDR, whatever you want. So, what were the challenges during creating this tool? Complexities in image processing, as I said first, I already explained when we were in modular structure, but converting all the image types to text were too struggling, and then we decided to use Selenium, and now it's 80-90% successful rate. Extracting malicious patterns, also I mentioned when we were in modular structure, with regex, we were able to extract TTPs and IOCs, but taking them with all packets were not possible with regex, that's why we use LangChain. GPT API limitations, at the beginning of the project, we were thinking creating some kind of source pool which includes maybe 100, 200 URL. When they are going to publish report, Perceptor going to be executed, and then we are going to see the result. But when we saw the cost for one URL, we decided to stop there because it has for each day we had to spend maybe $500, $600 because let's say every URL gonna publish one report for each day. For 200 report with $1.50, it will be too much. That's why we decided to go with just one URL, but we will try to solve this. And issues with PySigma implementation, because I already explained the problems about PySigma. MITRE attack mapping challenge, we saw that we can create some algorithm for techniques for example, if we are going to see CMD on IOC table, we can map to directly it's T1059, but after we saw that we had to give maybe 2 months, 3 months for create all algorithms for all MITRE techniques, will be impossible. That's why we use LangChain for MITRE mapping also. And Sigma rule syntax logic optimization, you solve the PySigma backed Sigma rules for syntax way, and it's not optimal. And the last challenge were the parsing and processing thousands of Sigma rules. If it will be 30 minutes, 40 minutes, our tool meant nothing, because you know, the main point that we are trying to do is taking the manual effort from the analyst. So we had to do it in seconds, and thanks to C-Safe Loader and concurrent feature technologies, we solved this challenge. So what are the impact and benefits?
Aytek talk about the internals and in-the-wild usage of Perceptor. We work hard, we saw many challenges and developed Perceptor at the end, okay. So was it worth it? We think yes. We believe that with this complete automation, we have increased the detection engineering process 10 times faster. Sorry for my voice.
It's hard, no?
Just a second. We believe that with this complete automation, we have increased the detection engine process 10 times faster. While it may normally take some time to analyze threat report and develop detection content, with Perceptor you can do this in a few minutes. Normally the report may take 2 or 3 hours, but with Perceptor user will see the all critical information and outputs in 3 minutes. That's why we believe that we have reduced the operational pressure by blue teams by 50%, especially against the emerging threats.
So, what are some exciting future works that we are working and trying to plan it? First, we are going to try to optimize Sigma rule output because, as I said, you saw Pi Sigma back detection contents. These are not enough for us for now. We are going to expand our CM and EDR queries. Like, you are not going to just see Splunk and QRadar. You are going to see also like cross-track IOAs, like the Sentinel queries also. And then we are going to try to give comprehensive report to the user after the execution with all the detection contents and all the information about the threat. And after, we are going to try to create some kind of prioritization mechanism for detection contents and also for the all threat report. And then for false positive reduction, for now we are reducing false positive a bit with LangChain, but we are going to try to do like with high percentage. And then we are going to try to also create continuous threat intelligence processing. As I mentioned, because of GPT API limitations, we will not be able to do it, but we will try to solve this. And lastly, we are going to create some structured database for proceed reports for community and for like some kind of correlations. If user going to give some URL to Perceptor, we are going to, like everyone going to see the outputs in one database. So it might be cool. And also we can correlate these outputs like with everything. So what are the conclusion? Like for example, the other persons were talked about AI. We are trying to do something with AI. It's undoubtedly cool. It's great, but still it's not a silver bullet. Like it needs the human review. It needs to like fine tuning. So it's not going to replace for like your job or something. It's kind of cliche, but it's not, maybe yet. But still, as I said, human validation is necessary. You might ask that if you are going to be able to use our tool. So we are still adding some features, some cool features. Like as soon as possible when we are going to finish it, we are going to publish on LinkedIn. You can like add us to see the source code for use, and if you can give some feedbacks, like at the end you are going to see the QR code for feedback session because it's tool and we believe the community strength, and if you are going to give some feedbacks will be great. Any questions? Like if you don't feel comfortable, you can find us like after this presentation. It doesn't matter. If it's not a problem, you can raise your hand. Any hands? No?
All right. Any quick questions? Okay, good. You can find them later in the hall. Thank you, Fatih and Aytek.
Thank you.